Hi guys, good morning. I hope you're able to hear me. Can anyone please confirm? Okay, perfect. Yeah, so till last session we have seen how we can use the Azure Data Factory in order to do the data ingestion, as well as even if you wanted to do the data transformation, we can do it, right? So by using the data flow, we can do transformation. And if you remember, while creating a data flow, we started data flow debug. Data flow debug we started in order to go for designing, or even if you wanted to run it, we need to have this. Okay, so this data flow debug is going to have a Spark engine, okay, or Spark cluster. Okay, when you run this data flow debug, why they're going to charge this a little more is because we are going to have a Spark cluster behind the scene. So for that reason, they're taking little more charge, more charge. And one more thing is, this data flow is completely user interface. So basically we were having, I wanted to say this, I'll come back to here. I hope I given this exercise right. You people have done this. That is fine. I wanted to say, basically this was like before going to the Databricks, I wanted to say there is a PySpark. Okay, or not a PySpark, let's say it is a Spark. Okay, so Spark designed with the Scala. There was a Spark. The Spark is a computing framework. Okay, so one kind of framework which is used to provide the solution for the big data. So the Spark was designed with the Scala language. Okay, again, Scala is designed with the Java. Okay, it's a different story. Just ignore it. I have a Spark. The Spark is going to be alternative solution for your Hadoop. Okay, so the Spark is going to be alternative solution for your Hadoop. So how it is going to be alternative? First of all, how previously before the Spark, what was computing that we are having? Okay, and before that, what we are having that I wanted to show you. I'll come back to this particular area again. So what happened is, very starting, before Hadoop, I wanted to say. Okay, so maybe you're aware of this Hadoop. Just ignore at least that name or term that you may come across Hadoop. It was sensational a decade ago. Okay, so before that we were having databases in order to store the data. We're all aware of SQL Server, Oracle, Teradata, Netezza. Okay, so there were various databases were there to store the data. And if it is a single system, okay, if you have a database within a single system, if the data is getting increased, then you need to increase the storage. And if the processing is taking longer time, then definitely you need to take a little more RAM. So for every single system, you just take your laptop itself. The best example is your laptop. So you'll be having 500 GB or something, right, as a hard disk, and you may have a 8 GB RAM. Okay, so if you're not able to store, if you have a data more than 500 GB, then definitely you need to increase. Okay, you need to increase the hard disk, and if you wanted to install few more applications to run in your system, then definitely you need to increase this RAM also. So RAM is need to increase, and the hard disk also need to increase, but you are going to increase within the same method. And like that, you can keep on increase and within the same single system. What happens is, even if you increase within the single system, that is not going to help us to store very huge volume of the data. At the same time, the performance of the system is going to be slowed down. Okay, so because we are doing vertical scaling, we are increasing the compute vertically. Okay, so we are feeding to the single person. If you feed more to the single person, there is no use. Okay, so instead of that, Instead of that, the Hadoop came into the picture with a different kind of architecture. Okay, so they came with a distributed mechanism. Previously, there was no distribution. Here, I mean, this is before Hadoop, there was no distribution. Everything will be there within the single server or within the single machine. Okay, so single machine means it's a very, very larger system, supercomputer, something like that. Okay, so later we got this cluster. We got cluster concept with Hadoop. So Hadoop, what they have done is, this is a node 1, node 2, node 3. Okay, so that means this is laptop 1, laptop 2, laptop 3. So 3 laptops were there. So to maintain these 3 laptops, there will be another laptop. Okay, just imagine. To control this 3 laptops, we will be having one more laptop. Or we can say it's a cluster. So cluster means collection of systems or collection of nodes. Node means a system. Node means a system. Okay, so collection of nodes are known as a cluster. So instead of increasing the compute for a single person, instead of feeding your food to the single person, we are going to feed for different persons. So what happens is, this person will do the work, this person also will do the work, and this person also will do the work. I gave example, if I'm correct, let's say if you have some work, if you do a work with a single person, definitely it is going to take your time, even if he is very stronger person. But if you have if you can do the same work with 3 persons, definitely you can do it very less. You can do it parallelly, at the same time you can finish as early as possible. And this system also having the storage, this system also having the storage, this system also having the storage. So that means each and every individual node is going to process the data, and each and every individual node is going to store the data. So that is what the cluster we are having it. So cluster mechanism is a collection of nodes are going to work together to get the solution. So this kind of increasing the compute, we can call it as a horizontal scaling. This we can call it as a horizontal scaling. Okay, so this is a distributed approach for the storage as well as even for processing. Processing also we are going to do. When we have a RAM, then we can do the processing there. Okay, so whatever the application it is, that may be Hadoop or that may be PySpark, that may be anything. So just leave it at this point of time. Some application can use to run parallelly. So this is going to improve the performance, as it is a distributed approach for your storage as well as for process, as well as for your processing. Now, how Hadoop was used to do the processing? Prior this Hadoop, we were having some tools like SSIS is there, Informatica is there. Okay, so data stays were there. Different ETL traditional tools were there. They were not capable to process a big volume of data. So big data was introduced. Big data means, I already told you, a data that cannot be stored in your system, or the data that cannot be processed with your application, then we can treat that particular data as a big data. So the existed the previous, I mean, the traditional tools were not in a position to process the data. Because of that reason, Hadoop came into the picture with a distributed approach. Okay, so in Hadoop, there were 2 things that we used to do it. In Hadoop, we used to do 2 things. One is, wherever you go, the problem for big data is process and storage. In the storage point of view, we can define that is a big data. In processing point of view also, we can define the big data. So for storage, we have a approach called HDFS. HDFS means Hadoop Distributed File System. HDFS means Hadoop Distributed File System. Hadoop Distributed File System, because your data, even if I remember at the time of Azure Data Lake Storage Gen 2, when you upload the file into Azure Data Lake Storage Gen 2, it divides the data into multiple blocks, and the blocks are going to be distributed across the different nodes. Even here also, when you load the data into HDFS, automatically the data is going to be distributed across the nodes. It's not going to store in a single place. But if you can store here, it will be there in a single place. But here you will be having a blocks. Okay, so multiple blocks we are going to have it. So because of that reason, the data storage is distributed and the processing also is going to be distributed. Okay. And in order to do processing in Hadoop, when the Hadoop was introduced, we were having the option called map reduce. So map reduce will be there. Okay, so by using that, we used to do the processing. So still in Hadoop also there were problems. The very bigger problem is environment. Environment is one of the big problem. And another thing is too much code. Okay, so you have to write too many lines of the code. Like you're aware of Java, right? This MapReduce was used to write with Java code. Okay, so environment setup is going to be huge cost because it is having completely on-prem. Okay, so what the people has done is, in order to make your 100% availability of the data, then we need to replicate the data. So this block is going to be 3 times available in the nodes, and this block also is going to be available 3 times, and this block also is going to be available 3 times in the storage. So more storage is required because if you have a 1 TB of the data, if you're making it 100% is available, approximately 100% is available, then definitely we need to replicate the data. So replicating of the data is like, again, it's going to be more cost. But companies are ready to bear that because with traditional systems, we cannot store, and with traditional systems, we cannot process it. So there were no alternative way. They went for Hadoop, even if it is having more cost on the environment. But this are all commodity systems. That means the cost of this systems is very less. Okay, it's not like a supercomputer. Okay, so the cost of the systems is very less. Normal computes also we can use as a cluster. So in that case, we can do, but environment setup is difficult. It's time-taking process. If I wanted to increase the compute or if you wanted to decrease the compute, it's not going to be easily possible when you go for the Hadoop. And another thing is, for developers, it is going to be very difficult as we are going to write too many lines of the code in order to process the data. So these two are the major problems that we're having. Okay, so before providing the solution for these two issues, I wanted to talk about how exactly the Hadoop was used to process the data. So let's say, for example, I have a data in the hard disk. I mean to say, I have a data in the Hadoop distributed file system. I have a data in the Hadoop distributed file system. I wanted to read the data from here. I wanted to read the data from here. To read the data from here, you have to write MapReduce program. Okay, so that means the data is there in the disk. The data is there in the disk because system is going to have a disk only, right, for storage. So you have to read the data from the HDFS disk by using MapReduce. Why you are going to read the data? To process the data. To process the data, you are going to read it. Once you have done some process, the process may be filter, the process may be creation of the column, the process may be combining of the data, some process you just imagine. Okay. So if you wanted to process the data, we need to read it from the hard disk. That means HDFS disk we need to read. And once you're done your process, then again you have to write the data into the HDFS. Okay, so again this is the storage one. Okay, for every transformation, this is transformation 1. If you have a multiple transformations, transformation 1 and transformation 2, if you remember, in Data Factory we used yesterday type 1 when we have taken select transformation and lookup transformation. Okay, so again, derived column transformation, conditional split transformation, filter transformation. So every individual item is going to do some transformation, right? In the same way here also, it's going to be done same thing. So what happens here is, when you do one transformation, the output of the transformation is not going to give it to the another transformation. Whereas in Data Factory, we have a feasibility. The output of the transformation will go to another transformation. But when it comes to the Hadoop, what happened is the output of the transformation will go and write the data into the hard disk. It is going to be written into the hard disk again. Okay, so and again from the HDFS, I mean, it is from the storage again. The second transformation is going to start reading data from there. Okay, because you cannot give the data directly, the output of this transformation will not go to the second transformation. That's not going to be possible if you go with the Hadoop. This is also is one of the major problem. Okay, so again, it is going to do some transformation. Again, it is going to write the data into the HDFS hard disk. Okay, so that is a major problem because this is a disk-based processing. It is going to be disk-based processing. That means many reads are going to be happen, many writes are going to be happen. So writing and reading is going to be, again, it will take time, right? So definitely it is going to take time. Okay, so that is one thing. And one more thing is the processing of the code is completely with the Java that we need to write it. So since it is a disk-based processing, it gives the less performance. So this itself is going to give more performance when you compare with the traditional system when the Hadoop was introduced. So later some point of time, the people realized, because when the data is getting slowly increasing, then definitely we have to think in different way. Why we need to write the data? So some people will get a doubt, right? So why we need to write the data into the storage? Why don't we give the data directly from the output of this to this particular place? If you can give it, then you can save the time. So this is the place the people started thinking, and they came up with a solution called Spark. Okay, so instead of doing with the processing with the disk based, if you want to give the output of this transformation to this transformation, then definitely processing where is going to be happen? The processing is going to be happen in the RAM. Processor is always going to be happen in the RAM only. So if you can do the processing in the RAM, then we can give the output of this transformation to another transformation. So this is the place they started thinking, and they came up with a solution. Okay, so that is what the Spark processing approach. So that's what I told you, right? Instead of giving to the hard disk, we can directly give it to the another transformation as an output. Even your data flow also follows the Spark processing, because behind the scene we have a Spark only. Okay, so when you have a data flow, 100% there is a Spark cluster. That's fine. We have a data in the same HDFS disk. I have a data in the HDFS disk only. And the task one means that is a processing, process one. This is going to read the data from here. So what is this? This is a Spark processing approach. How the Spark is going to process it. Okay, so what happens here is it is going to read the data and keep the data in the RAM of it. I mean to say the transformation is going to be applied. Of course, on top also it is going to process the data in the RAM, but it cannot give the output of that to another process, another transformation. So that was the problem. So here it is going to give the output of the task 1 to task 2. That means process 1 to process 2, and process 2 to process 3, and so on. So it is not going to write the data to the disk. So that means we can read only one time and we can write only one time. We don't need to write multiple times, and we don't need to we don't need to write multiple times. Whereas in the Hadoop disk-based processing, then definitely you have to go for multiple reads and multiple writes. So that is the problem. And in order to process the data in the Spark, we required more RAM. Okay, so much more RAM is required. Here we don't need a RAM. We don't need a much RAM, because they're giving the output of this to, and again hard disk, so we don't need to have a huge RAM. But here we require. So there is many things are there in order to performance, in order to utilize the RAM space. Because if the RAM is if the RAM is full, then you are going to get in memory issues. Okay, so to avoid it, how we can handle that, I'll talk about it later theoretically. Okay, so how this Spark system is going to help us to provide the solution. Okay, so what happened is, I'm just, before going to this, I wanted to come to this particular place. Okay, so Spark designed with the scalar. Okay, so in order to do the in-memory processing, they came up with the Spark. And they made this Spark as an open source. Okay, so they gave this Spark to the Apache, and when you gave it to the Apache, automatically it is going to be a free source. Okay, open source it is. So since it is an open source, everyone can take this source code from the Apache. Okay, you can take, I can take, and others also can take it. So like this, the people who designed this Spark, those people gave it to the Apache as an open source. And then when you go with the open source, that means whatever the version they have given to the Apache, that version is going to be replaced of your Hadoop. That is true. But there are some issues for the developers. The issue says it's not having it is not having development interface. I mean to say, it is having, but you have to write. I mean to say, IDs are not available. So integrated development environments are not available. Okay, so I'll tell you what do you mean by that. Okay, so you can understand. So on top of this, to make it much more useful for the developers, to make it much more easier for the development teams, the people who gave to this, they started a company. They started a company called Databricks. They started a company called Databricks, and they have given the interface for the. They have given interface for this Spark. Previously, interface is not there. It's a CLI. Okay, so Databricks company gave the interface for the Spark. So what we can say is, they took the open code. I wanted to say, it's an open code, open source. Everyone can take. So Databricks is a company. Okay, so Databricks is a company. Working directly with the Spark is little difficult. Okay, so you can feel more or less say with Hadoop, but only thing is Hadoop is going to ask you to write Java code, but Spark is going to ask you to write a code Scala, Python also. You can write Python, you can use the Python, and you can use the Scala, you can use the R. Okay, so options are available in a Spark. Okay, so that is the one of the best feature that they brought in Spark. But only thing is, the environment is little difficult for the developers. Because of that reason, Databricks company designed the Databricks UI, user interface. They designed the user interface for better development approaches. Like this, there are many people has taken the open source open code. That means source code. So who has taken? ADF also has taken. ADF designed data flow. ADF design and data flow. It's a Microsoft company. Because this is for everyone. This is for everyone. Okay, so open source is for everyone. Everyone can take it. Even what I can say, I'm not exactly sure about the tool name, but even from AWS also they have it. Blue or something is there. If anyone knows, you can give me the spelling of that. AWS. AWS also took the code. Okay, subject to correction. If anyone knows, let me know. Okay, so Bloom or something is there. Not sure what is the name of that, but they have also tool. Okay, in order to process the big data. Okay, so these people also has doing it as it is an open source. Microsoft made this as completely user interface. We have seen completely user interface. We don't need to write a code. So here you have to write a code, but not sure about this. You can search about this if you wanted to know. So here you have to write a code, but comparatively this, it is much more easier. And comparatively this is much more easier for the developers. Everyone can easily understand. Okay, so if you wanted to do the broadcast, if you remember, we talked about the broadcast, right? So broadcast, we don't need to do anything from our side. Automatically, ADF will take care. If you want to control it, you can control, but when you come to the Databricks or when you come to the Spark, you have to take care from your side. Okay, so this is about the Databricks UI. Yeah, Glue it is. Thank you. Okay, and apart from that, I wanted to say this is this came later in the stage. Okay, so after this only this came into the market, because here also we are having a code. So why don't we design our own user interface? So Microsoft has done. Apart from that, this Databricks company associated with different vendors, because Databricks stays in the cloud. Databricks stays in the cloud. So these people are associated with different vendors. They are associated with Azure. They are associated with AWS. They are associated with GCP. With these three, at this point of time, they associated. So when they associated with the Azure, we are calling this as a Azure Databricks. So when you know the Databricks here, then you can work with the Azure, you can Databricks. So Databricks environment, 98% is similar. You can feel the similarities of it. Only thing is, the infrastructure is required, compute is required. If you remember, if I told you right here, compute is required. This is going to be provided by Azure. This is going to be provided by AWS and GCP. But the application is the right. This Databricks company, this Databricks company designed this Databricks UI by using this Spark. So this UI is not available for Azure. I mean to say Azure is not having this kind of user interface. AWS is not having this kind of interface. Okay, so this kind of things is not available. Because of that reason, they are associated with this Databricks. So user interface is from the Databricks company, and the infrastructure is from the cloud platforms. Okay, so when we take this, we have to pay the license for this and for this also, or for this or for this. Any of the two combinations we have to pay. But we don't need to pay individually, separately to the Databricks and separately to the Azure. We are going to pay the bill to the subscription. The subscription will take care. Okay, so that will be a headache of the Microsoft and Databricks. So you don't need to worry about it, how they are going to save the bill. Okay, so we are going to be a unified billing system. We are going to have it. Okay, so let's come back to here. Now I wanted to tell you how Azure Databricks architecture is going to be there. I told you, right? Databricks will be there and Azure will be there. So two companies are there. Okay, now it is much more visible. So two parts are there. One is the Databricks company part, and other is Azure company part. That means Microsoft. So what these two people are giving? When you create a Databricks in the Azure, how exactly the environment will be there? I'll show you. Practically, we are going to see that. So two things were there when you go for this. I wanted to come little down. I think I don't need to come. Yeah. So in the Databricks side, we have a few things. Databricks web application. This is the place where we are going to do the development. It's a UI. So Databricks company is providing the Databricks UI to write the notebooks. So here we are going to call them as a notebook. Okay, so notebook we are going to create as part of with this particular thing. When we see practically can understand how exactly it is going to be there. It's like a when you write a Java program or when you write a Python program, we are going to have some kind of file, right? So here also we are going to have, even this is going to store as a py, a different kind of things, but it is going to have a .py. If when we are writing, when we are writing as a PySpark, okay, it's all depends how exactly it is going to be there. That's fine. Here we have a Databricks way in order to write the code and where we are going to create a notebooks in the particular environment only. And apart from that, you'll be having the jobs also. Once we created notebooks, then we need to create a jobs to make automation. Okay, so the creation of the jobs also we are going to do in the Databricks side itself. And cluster manager. Cluster manager also is going to be provided by Databricks. I mean to say from the Databricks itself, we are going to have it. Okay, so we have a various types of cluster managers. You don't need to worry about what kind of cluster manager they're using. Okay, so everything will be taken care by Azure itself. I mean, it's a Databricks itself. Okay, so that is a cluster manager. But when you go for a Spark, then you have to take care setting up all the things. So environment setup, you need to take care if you go for the pure Spark. But if you go with the Databricks, we don't care about how the environment setup is done. Everything will be taken care by Databricks as well as Microsoft Azure. Okay, so you don't need to worry about all those things. So many things they have taken headache and they have given environment for us to go for the to go and concentrate more on the development. And then when it comes to the Azure side, then data also we need to store. Okay, so without data storage and without cluster. So I told you to process the data, we required a cluster. So who is going to provide the cluster is Microsoft is going to provide the cluster. Okay, so how exactly it is going to be there? How many nodes? Depends on your requirement. You can create a cluster. You can create a cluster from the Databricks. When the moment you create a cluster, it is going to take the compute from the Azure only. How many node means virtual machine. Okay, so node means a system, a laptop. Okay, in general naming standard I'm saying. So how many number of nodes you require, that is going to be assigned. So how many number of nodes you require, you can specify at the time of creating a cluster. At the time of creating a cluster, you can specify how many number of nodes you require. So the cluster will be up and running when you create it. Okay, so it is going to be up and running. If it is up and running for 1 hour, then you can pay for 1 hour. Okay, so you don't need to pay if it is not running. If you're not utilizing the resources, you don't need to pay. So that is one thing you need to keep in mind. And once your work is done, if your practice is done, then if you want to stop this cluster, you can stop this cluster. Now you may get a question in real time. If it is continuously running, then how it is? If it is continuously running, 24/7, you have to run it, right? If it is not running, then you cannot utilize it. Okay, so if that is the case, then definitely there will be a huge cost. If you don't use this cluster properly, then definitely it is going to be huge cost. So because of that reason, even Microsoft or Databricks came with two types of cluster modes we're having. I'll talk about it, how exactly it is going to be there. So what are the different types of clusters we can create? So depends on your requirement, you have to choose the clusters. We have a all-purpose cluster and job purpose cluster. So if it is a job, you have to go for different approach. If it is a development, you have to go for different approach. So I'll tell you how we can create them while creating these clusters. And so the parallelly, all these nodes are going to process the data, and every node is going to have the RAM. Okay, so you can define how much RAM is required at the time of creation of this cluster. Every node has its own RAM, and every node has its own cores to process the data as per the business requirement. Okay, and for this also they require storage. Why they require storage? The reason is we required metadata store, right? Okay, so when you store the data, when the processing is going to be happen, which file or which node is processing in which node, what we can say, which block is processing in which node. If you wanted to know it, then we need to have a metadata store. For metadata store, behind the scene, we are going to use the Azure storage ADLS Gen 2. Apart from the data storage. The data storage, you can take Azure Data Lake Storage Gen 2 account as a separate. Okay, but when you in the cluster itself, in the Databricks itself, we are going to have Azure Data Lake Storage Gen 2 account. You are not going to create it. Your Databricks is going to create. That means when you create an account, when you create a Databricks workspace, you are going to have a compute, and you are going to have a storage also. Apart from your storage, like when you practice ADF, you have taken input directory and output directory, if you remember. So that is common. Apart from that, one more storage is going to be created internally when you create a Databricks account. Okay, so that is how it is going to be there. I have a one Databricks account, it says service. I'll run that one presently, but I'll show you how exactly it is going to be there when you create. Okay, in the next session, I'm going to show you how we can create it. But let me do one thing. I have a existed Databricks. I wanted to run that. Let's go to resource group. If I create it, it is going to create for you also. So for that reason, let me utilize the existed Databricks. I'll show you how that it is going to be there. So this is a Databricks, and where is the storage? Resource group. Yeah. So let me duplicate this space. Otherwise, let me create it so that you can understand what it is going to create. Let me close this and go to your resource groups. There were 3 resource groups up there. Out of these 3 resource groups, this is all the services are going to be there. It's a general resource group it is. If we observe, there is a resource group called the second one. mrg bhaskar-adb-dev resource group is there, right? This is going to have a default storage, that is ADLS. Okay, so I'm going to create a service, a new Databricks account I'm going to create. Just observe. Let's search for the Databricks. Let's create. There is only one Databricks was existed. I wanted to say separate resource group I'm taking. Bhaskar-dev is my resource group. I'm just giving delete also for sake of my convenience, because I'm doing something with existed resource group. So if I delete it, unfortunately, then I'm going to lose many things. So to avoid it, I'm just creating a resource group with um, suffix delete. Let's hit OK. And I'm just going to say adb hyphen Bhaskar hyphen delete. Here also I'm just following the same suffix. I'm just going to take a standard here. Okay, you can don't go for free trial, guys. Just leave it, because just create a standard if it is allowing with a free trial subscription. Okay, if it is going to be ended within the next 14 days, then you can go and create it. Okay, so if you're having a paid subscription already, if your subscription is converted as a paid, do not create this trial. At the time of project, we can use that. Okay, so at the time of project, we can use, instead of going with the premium, we can go with this, because some features are not available with the standard. So when I go for the project, we need to have a premium capacity. So for that reason, do not create a premium. I mean, it's a free trial premium if you have a paid subscription. If you have a free trial subscription, you can do it. But if you have a paid, then if you're not going to create a one more account, then do not create it until unless we go for the project. Okay, so otherwise we have to pay some license cost. So I'm taking a standard here, and we need to create a managed resource group. So why we need to have a managed resource group is we need to manage all this stuff. Okay, so what are the how many nodes are there, nodes information, and blocks information, how exactly the data is distributed across the different nodes for processing. So this is not for storage. Okay, so this environment is not for storage. This environment is for process, only process. We're going to have a RAM. Okay, so the metadata details we require to handle it. For that, we need to provide a managed resource group. I wanted to say mrg underscore, not underscore, hyphen Bhaskar hyphen delete. I'm just taking this, something like this. Let me keep dev also. So like this, I'm just giving it. And just review plus create. Don't go for anything, because we are not going to be part of all the stuff. Let's go for review plus create. And create it. It takes 3 minutes. Takes 2 to 3 minutes to deploy. It's completed. Let's go to resource. And we can launch the we can launch your database. So the way we are having the Azure Data Factory workspace, right? In the same way we have a Databricks workspace. We just launch this separate URL is coming. You can see here. So this is a Databricks user interface. That is what it is. Databricks web application. By using this web application, we can create a notebooks. So there is a workspace. Under workspace, you can have a repos we are going to see. And there is a workspace, you can create a notebooks here. So something like create a notebook. I'm just going to create a notebook. Anyhow, I'm just going to remove this. Okay, so I wanted to say print welcome to Databricks. When I try to execute this, it is not going to be executed because I don't have a compute. Compute is required. A cluster is required. Okay, so you can see you don't have an available compute resource to which this notebook can be attached. So please create a compute for this. If you don't have a compute, then you cannot do it. I'm going back to the compute here. So compute is going to have two different options to create a cluster. Compute means a cluster here. Okay, so it's not a single mission. 100% it is going to be multiple missions. So to create a cluster, if you go for Hadoop, it is going to take very longer time. And even if you go for Spark, then the cluster you have to set up from your side. But when it comes to the Databricks, it's very easy to create it. They have given the user interface. The way you created a service, in the same way you can create a cluster. I have two different types of clusters. One is all-purpose cluster and other is job compute. All-purpose compute and job compute. So two different types of computes we are having. So when we can use this all-purpose compute and when we can use this job compute, we'll talk about it. Okay, so I'm just going to, the time is not going to be suitable to create even this. Before creating a cluster, I wanted to show something here. Let's go back to the home and resource group. You created delete resource group, right? Bhaskar F1 delete resource group. In the same way, there is a MGR Bhaskar dev delete also. Inside this, we are going to have a storage account. What type of account it is? It is a Azure Data Lake Storage Gen 2. If you open this and see hierarchical namespaces enabled, it's a ADLS Gen 2. That is what I'm saying here. We're going to have a Azure Data Lake Storage Gen 2 internally as part of the Databricks. Okay, so as part of the Databricks, we're going to have it. Okay, so that is one thing I wanted to say. Let's come back to here. And when you go to this, the main resource group, two resource groups are going to be created. One is for manage and other is for workspace. So when you go inside the workspace, you have a Databricks here. We have a database. And I'm going to duplicate this page. Anyhow, I have to talk about these clusters. Okay, so it will take time to finish that because when I create a cluster, what is going to be happened in the Azure side? That I wanted to show you practically so that you can get an idea how these virtual machines are going to be created. Okay, so for a free trial account, the number of clusters will be limitation will be there. Okay, so if you have a paid subscription, then you can have as much as required. So for practicing, we don't need too much. We can have minimum configuration. Okay, so go with minimum configuration to avoid the cost. So example is these are all the Databricks. Okay, so how we can write it, we're going to see. And this is a community edition. Okay, so community edition is different and main Databricks, Azure Databricks is different. This is a chargeable and community edition is not going to be chargeable. So in the next session, I'm going to show you how we can create a clusters in the Databricks And then I'm going to show you how we can create a community edition for our daily practice. For project, I'm going to use a Databricks, Azure Databricks only, the paid subscription. And for daily practices, I'm going to use a community edition to avoid the cost. Otherwise, you are going to take, you have to pay a little more cost. Okay, so for to avoid that, this is the best practice for practicing. So few features are not available here. Those things we're going to cover as part of Azure Databricks. Okay, so I'm stopping here. I'm not creating a cluster. I will see that in the next session. If you have any question, you can unmute yourself and ask a question.
Hello.
Yep.
Hi, sir. I have one issue. Can I share my screen?
Yep.
Just
you
a
can.
second. Just a
One
second.
minute. Let me stop my screen. And I'm going to give an option to you.
Yeah.
You want to share it?
Yeah, I want to share my screen.
Yeah. Now you can try for sharing. Okay.
Yeah, I created a pipeline for SCD type 2.
Cluster.
And
Start the cluster.
just,
Data flow
flow.
debug. Data flow debug.
Data flow debug.
In the data flow, you can say, right? Go to the
This
data
one,
flow.
right? Yeah.
Not that one. Not that one. Go to data flow. And
Okay.
here there is a
Oh,
data
this.
flow.
Okay.
Okay, so what was the problem?
Like, I am getting records multiple times.
Did you follow the same thing the way I
Yeah.
done? Okay. Show me the tables first, how you have created the tables.
These are the tables. Like, this is a source table.
Okay. Okay, perfect then. Go to the data factory then. Go to your data factory.
Yeah.
Can you increase the size? Little more size.
Okay.
Stay in the data flow. Okay.
Okay.
Increase little more.
Is it visible now? Like I guess
No,
it will be visible.
I need a name also. Little more. You can increase.
Oh.
In the right side, there is a plus. Yeah. This much. Exactly. Can you open the source customer? Can you show me the query? Okay. Select star from table name. That is fine. Can you show the target query? Select target customer and show me the query. Maximize that. There is edit button, right? Hit on edit. Okay. You're taking all of them and it is null. Perfect. Okay. Close this. Cancel will be there somewhere. Okay. And go to lookup. Scroll down. No need to go for reducing. Yeah. Go to the lookup and show me lookup condition. Source customer ID, target customer ID. Perfect. Okay. Next one. New rows. What is the expression? Is null of customer key. Target customer key is fine. Existed records is fine. Okay. Come down. Next one. Go to the select is fine. In the existed, for existed and filter. Go to the filter. Show me the filter condition. Expression builder. So customer name is not equal to target customer or source location is not equal to target location, or source sales is not equal to target sales. This is also correct. Okay, cancel. And next is select 3. Okay, not that one. Select 2. Go with the select 2. Which columns you have taken? Source columns only you have taken. This is also correct. Okay. Go to union. Okay, this is also fine. Okay, so next,
I think here I need to put union select 3. Like this is attached with country.
can you select the can you go to the select 2 only, not select 3. Can you go to
Okay.
select 2 again? Show me the list of columns. Yeah, this is one only. That is correct. Union and start date. Take a sync 1. Settings. Okay, that is fine. Go with the sync 2. Allow update only. Key column. Okay. Can you go to alter row transformation? 1 equal to 1. Okay. Okay, so do one thing. Truncate your target table. It's correct only. And one more thing. Can you go to third, select 3? After select 3, we have, can you go to, okay, select 2, we'll go for that. And yeah, select that end date. What is the columns I have? End date. Where is the customer ID? Can you go to previous transformation? Select 3. This customer key was not there, right? In the next transformation, first key is required.
Start date.
Here.
End date.
What is the output of this? Can you go to data preview here? From sources. Maybe it is there. Check that connectivity. No. Okay, let's see. Okay, so can you show me that end date only? Okay, that's fine. That's fine. Do one thing. Go to your target table and truncate the target table from SSMS. Target table only.
Okay.
First connected. Now no data is there, right? So 1 minute. This cust key is an identity column. In the target, you have to give identity. After no, hold on. Drop the table.
Drop it.
Drop the table. That was the problem for you. There is a cust key is there, right? After cust key, make identity. After cust key, before int type. Yeah. Now write identity.
No, first int data
Int,
type.
okay. Then give int first. Then identity of 1, 1. Bracket open. 1, 1. Close. Yeah. Now you can test it. This was missing. Not in the master database. Select your database and create it. No.
Okay.
How about others? Anyone faced any issue?
Shall I truncate the table?
Not
So
required.
that
Not required. Save new table only. You can say select star from customer. You can execute that.
yeah, I executed this.
No. Why? How data is
First
coming
drop.
here?
First
Drop the
drop
table.
and
First
create.
drop the table. I thought you dropped it.
Now create
Yeah.
with identity.
Now if you say select star from table name.
Select.
Okay. So when you're testing, target should not have any records. Now only execute do one thing, truncate. You connect here also. Select the database. First truncate the table. Okay, insert only one record. Now run your pipeline. Wait for some time. Anyone having any question, guys? Meanwhile,
I have one doubt, sir.
yeah.
Sir, in a Spark processing approach, so we have some limitation in the memories. So to overcome this,
We are going to talk. We have to clear the RAM. Okay, so we have a partitioning mechanism. It will be there.
mhm,
Okay, so we have to clear the previous occupied memory. Okay, so that we'll be having enough memory.
okay. So I
Okay,
mean, in the Spark architecture, so it will use the only memory.
yes, in memory processing.
So earlier Hadoop process and everything they use some kind
Disk-based
Disk-based.
processing.
So to overcome that Hadoop, so Spark architecture can.
Yes. Not only that processing thing, they came with a new language. Okay, so
Spark.
they replace the Java with Scala. Now insert one more record. And go for running again. So we can write a less number of lines of code when you go for the Spark architecture. I mean the Spark approach.
Okay, inside Spark we can write Python.
We can write Python, we can write a Scala, we can write R. So
Okay.
Databricks or PySpark is for everyone.
Okay.
Okay, so they have given much more feasibilities and disk-based processing. So they are given the fault tolerant solution also, even the way Hadoop handles. Hadoop fault tolerant is different and Spark fault tolerant is different. And we can utilize the memory. We will be having a data flow diagram. Okay, that means a DAG will be created, direct acyclic graph. Okay, so we are going to talk about it. So it's too early to check all of them, but we are going to see.
So in simple term, what is difference between
Hadoop and Spark.
Hadoop and Spark? Can you name it?
We can say Hadoop will support for disk-based processing, whereas Spark will be in-memory processing. So if any of the application provides processing in memory, then the processing of the data will be faster. So how many times it is faster is 100 times or 10 times is faster than your Hadoop.
Okay.
So that much faster this. I guess 10 times or 100 times. I'm not exactly sure about the term. Now you understand, right?
Yeah.
Yeah.
Okay. I mean to say this data flow.
Yeah. Okay.
So I'm talking with both of you. Yeah.
I have one more question, like why we are going to this SCD1 and SCD type 2, like we can directly transfer data from source
historical
to sync,
data. Historical data. If there is
no,
an update,
that is we can directly transfer like data from source to sync by using copy data activity, right?
that's
Like
what
why
I'm
we are
saying.
going.
That's what I'm saying. If you change your address, then can you capture your current address, previous addresses? Apply yourself.
Okay.
You're getting my point, right?
Yeah.
If in the business system, current data only will be available.
Okay.
Okay, you are not going to have a historical data in the current system. I mean to say in the business system. So business system never maintains historical data. So if you need a historical data for future understanding, if you wanted to compare your business, what was my business with the current month and previous month, that is one kind of comparison. Or let's say this month is April, right? April 2024, how was the sale and how was the sale in March 2024? That is one approach.
Like,
Another
how can we look into that historical data? Like where we can get that historical data? Like
here and I will tell you. You just update one record.
okay.
Okay, update one of the existing record, not in the insert statement. You have to write update statement.
Okay.
Okay, so execute it and rerun the pipeline. Before that, select star from target table.
Ingestion.
Yeah, there were two records are there, right? Just have a look on this area and run the pipeline. All the history will be there for that particular person. Okay, if you don't have a history means like even if I wanted to compare 2024 April and with 2023 April, then 2023 data is required.
Okay, then what is the difference between this SCD type 1 and SCD type 2?
You have to tell me. What did you observe when you practice with SCD type 1 and type 2? SCD type 1 will not maintain historical data. It gives only current data.
Okay.
Okay, so if you go for type 2, then historical data is required. Simple example, like if you're working as a permanent employee, then they're going to maintain historical data. Okay, but they need a historical data. But if you're working as a contract employee, they don't need your all those details. So that particular point of time they need.
Okay. Then what is the use of this SC type 1? Then we can directly use that copy
No,
data activity
it will
and
be
we
there.
can.
Man, we required you can use it, but the problem is if you use the copy data activity, just try to do the same thing with copy data. Okay, do one thing. Insert 2 records in the table and use the copy data activity, move the data into the table. Your target should be a table. And again,
Okay.
do modify in the data source and try to run it. It will go for double. Data is going to be double. It is going to be inserted because we are not checking any condition. So SCD type 1 is required. You cannot go with only copy data flow. It is going to append the data with copy data. Go and see the
Okay.
target now, target table. Now for 1, you can see what is the latest location.
Okay. This one.
Delhi is the latest location, right?
Yeah.
Hyderabad is expired. There is an end date.
Yeah. Okay. Okay.
Okay, for every record there will be end date if it is expired.
Okay.
Okay. Now only 2 records, only the new records. Of course, the same customer ID 1 and 2. Only thing is the 1 is having 2 records here. The older records also are available.
Okay.
Okay. Anyone
Okay.
else? Any other question, guys?
Thank you, sir.
So one question, literally. So
Yeah, Srini, I
X-
have seen
X-
your mail. I
Yes, sir.
didn't get a chance to look into that. Okay, so
Okay.
one day we'll take and only is Srini only attempting it? Is there anyone else also attempting?
It just did, sir, but not in Databricks.
Okay.
ADF, SQL, SSIS, SSRS, Power BI.
Okay, so if interest schedule, please try to make a note of your questions. That will be helpful for others also.
Yeah,
Yes,
sure.
Srini, you can ask a question now.
Access keys, yes, sir. Authentication.
Okay, so did you remember when we use the data factory, we have not used any access keys to access the data. Okay, but that is not going to be real time. Whatever we have done in the data factory at this, whatever we completed at up to now, that was not the right practice. Okay, so there is a SPN service, SPN service principal name we are going to use to handle it. When we come across the project, then you can get to know how exactly we are going to handle. So that is one of the approach with service principal. And apart from that, we are also going to have a Azure Key Vault. Okay, so these two are the recommended options to do it. But apart from that, these two we are going to cover. Okay, so at the time of project, we are going to say. And if you remember, we have used Azure did we use Azure Storage Explorer?
Key1, Key2.
Yeah, right.
That,
So the
yeah,
K1
that I
and K2
told.
we can use, but
Yes.
that is visible. Okay, so if you're seeing that key means that is exposed. If it is exposed, there is no security.
Yes.
Okay, so that's not the right answer. Once we come across the project, you can get to know more in detail.
Yes. Yeah,
Okay,
just
so
I said
yeah,
that Azure Key Vault is there. Like
you
that
can
I said.
yeah,
Manage
so,
it.
no, and again, one more thing is Azure Key Vault. There is one more problem is there for data lake storage and too. In my project, we are recommended to go with SPL service. SPL means service principal name. Okay, we can go with SPN. When we use the SPN, then we are going to use the option called system assigned managed identity. You can say what we have used in order to connect, because we are not going to get individual access. We are going to get the access to the data factory. Okay, so data factory will be having access to read the data from ADLS, and data factory will be having to read the data from the database also. Okay, so in order to do all those things, we are going to use SPN, a service principal name. So when you use the service principal name in data factory, we have to use the option called system assigned managed identity. Okay, that is the real time. And Azure Key Vault also for databases, we can use Azure Key Vault also. I'll show you these two options. And even when it comes to the Databricks also, basically for practicing, we can go with the keys, but keys should not be visible. If key is visible, means that there are 100% chances to violate.
And that should be encrypted.
Yeah, we have to use the secrets. That means Azure Key
Yeah.
Vault secrets we need to use. So we'll talk in the further sessions. Okay, anyone else? Remaining?
You're
aware of it, right?
Yeah, almost I answered some.
Okay.
So creating the pipeline and pipeline. So there is execute pipeline is there. From there we can invoke second child pipeline that I answered.
Yes.
Here's some of the SQL questions they have.
Okay.
So now they move to second round. I have second round.
Okay. Very good. Very good. So once this course is completed, then you can easily crack the interviews. And again, conditions apply. Only if you do practice, then only it is possible.
Yeah, they're asking how do we can create the pipeline. So from integration service to linked service creation. So confidently we are able to explain that.
Yes. That is true.
Maybe that impressive. And second round is
okay. Good. Good.
For two companies I selected for second rounds.
Okay.
So by next week, definitely.
Yes, you just imagine we are in the middle of the course. Actually, exactly we are in the middle of the course. But you are in a position to clear. So once this is completed,
so maybe I was experienced that I'm getting calls. People are.
Yeah, definitely experience is required. Okay, so to have a more calls, definitely experience is required. If you have a gap, you can, most of you know how you can fill the gap. Okay, so do in that way and you can get it.
Spark SQL there.
Spark SQL is nothing but a SQL only.
Yeah, data frames, this knowledge, hands on experience is there. Yeah, then we can ask questions that they are saying.
Definitely, because we are not started, right? So there is a chances to lose the answers from this particular area.
Yes.
At least the next 15 days, by next 15 days, we are going to get minimum knowledge with Databricks.
Yes.
Okay, so how about SQL? Do you have experience with SQL previously or?
Yeah, I meant to SQL.
Okay. Then it is
so
easy
they're asking like what does material is SQL question. So it's combination of their role they are asking like combination of MS SQL and ADF and Azure Data Factory. Like that, the exposure is like roles and responsibilities. So
exactly.
When we keep this in resume, they are calling. Only SQL, we won't get the calls.
Definitely, 100%.
That
is true. So we need to have this skill set, then we can get it. So everyone, please even start doing Databricks practice continuously and continue your Data Factory practice. Like some people maybe think that Databricks depended on Data Factory. No. So Data Factory is independent service and Databricks is independent service. So if you have any pending from Data Factory, so you can parallelly continue your practice. Do not hold your Databricks practice. Okay, so maybe from next session itself, we are going to start doing the practice with Python. So daily do complete practice.
Sir, I have got one student account. So is it enough? Because it credits $100.
That is not going to be sufficient.
So,
Many things. Yeah, that is not going to be sufficient.
okay.
You can use only $100 only. You cannot. And not sure about the services.
Yeah,
How
yeah.
exactly they're going to give. That
Services may give, but credits may not sufficient. I think.
Yes, may not sufficient. That is true. And even if you go with the paid, that will not take much more amount. You can try. Once you get a job, that's not that will be nothing for you.
Yeah.
Okay. Okay, then please keep post if you have interview questions. I will take you through again. Okay, so
Yes,
you people
yes.
need to give the answer most of the questions. Even when I work through all those things. And who are attempting, try to list of them and send it to me. We can discuss. Okay, then thank you for joining and happy weekend. We'll see you on Monday.